Good afternoon, and thank you so much for joining us today on this first international virtual colloquium on engineering, sciences, and technology and the link with the Sustainable Development Goals. Today, I'm going to present the host, and this will be Miss Ana Isabel Boyd. Welcome, everybody.
Good afternoon. On behalf of Technological University of Panama's International Affairs Office, allow me to extend a warm welcome to everyone present at the closing session of the first International Virtual Colloquium on Engineering, Sciences and Technology and the link with Sustainable Development Goals. During this first work table, we will be addressing the topic, Integrated Management of Water Resources and its Importance in the Fulfillment of the Sustainable Development Goal number 6. As we know, water is an irreplaceable resource which is fundamental for socioeconomic development, healthy ecosystems, and for human survival. Its proper management and sanitation throughout the use of new technologies have become a necessity to reach environmental sustainability on water to ensure a better quality of life. The methodology that will be used for the organization of this roundtable will be the following. First, each expert will have up to 10 minutes to make a short presentation related to the central theme of the table. Later, we will have a question and answer period where the speakers will answer questions from the public. These questions can be left in the YouTube chat during the presentations. Finally, we will have some conclusions from the speakers. And to begin, our first expert is Dr. Jose Fabrega. He has more than 20 years of experience as a researcher in various areas of environmental engineering. Recently, he has focused his efforts on issues related to the water and carbon cycle, river basin management, and climate change. Dr. Fabrega obtained his civil engineering undergraduate degree from Universidad Santa María la Antigua in Panama. Later, he obtained a master's degree and a doctorate in civil engineering with emphasis in environmental engineering from Purdue University, Indiana, United States. He has been a principal investigator and a co-investigator in multiple research projects funded by the National Secretariat of Science, Technology, and Innovation of Panama, the International Atomic Energy Organization, and the Cooperation Agency Japan International. Dr. Fabrega is currently the Interim Director of the Center for Hydraulic and Hydrotechnical Research of the Technological University of Panama. In 2019, Dr. Fabrega was appointed a member of the Global Water Partnership Global Steering Committee, and in 2020, he was elected President of the Panamanian Society of the Advancement of Science. Please welcome Dr. Fabrega.
Okay, so we are having some issues right now. I think, Anna, we can continue with our second speaker. And as Dr. Fabrega is back, we are going to continue with him then. Okay?
All right, in that case, we'll follow with our second speaker of this roundtable, which is Dr. Jin Wan. Dr. Guan obtained his undergraduate degree in water resources and hydrology at Hora University, China. Later, he obtained a Master of Science in Hydrology at the Delft Institute for Water Education. Then, in 2003, he earned his Doctor of Philosophy in Environmental Hydraulics at the Swiss Federal Institute of Technology, Switzerland. He has been the Vice Director of the International Office at Hora University since 2007 to the present date. Since 2003, he has had functions as Associate Professor of Hydrology and Water Resources at Hora University, teaching and researching water-related issues and supervising diploma work and graduate students. He also worked as a research assistant at the Swiss Federal Institute of Technology from 1996 to 2003, and at Delft Hydraulics from 1996 to 1998. He also did his lecture in hydrology at Hora University from 1988 to 1994. Please welcome Dr. Guan.
Dr. Guan, your microphone is off. Sorry, can you turn it on? Dr. Kwan? Are you able to open your microphone right now? Okay, we're having just some issues, but thank you so much for all the viewers right now. Just we're at home. Everybody right now is even our speakers. Yes, Dr. Kwan, your microphone is on right now. Can you hear me? Okay, we're having some issues with the platform right now. If you can, Dr. Kwan, just to exit and enter again so that we can make sure, because right now we can't hear you. I see your screen. I see you're sharing the screen. It's just that we can't hear you. Okay. Yeah, I recommend you to exit the studio and enter right away because we're having this little issue with the platform, and yeah, we won't be able to hear you right now. Okay. No, we're not able to hear you right now. Yes, that's why I would recommend you to exit the platform and enter again so that we can just go ahead, I think. Okay, Anna, so we're having some issues with the platform. Nothing to worry too much because, I mean, yes, there are always things that happens when it comes to this virtual activities. And just to let know all the viewers, we are having our speakers from different part of the world. So they're actually in China. So that's why we have this is the only way that we can have them right now. So we're just making sure that we can hear them clearly. Let's try again and see, Dr. Kwan, if we can hear you. Not yet. We are not able to hear you. Not yet. Yeah, I would recommend you. Perfect. Yes. So he's going to try. Give me 1 second. Okay. So what we're gonna do, Anna, I don't know if you agree. We're going to make a little change of the agenda that we have for today. We also have other speakers. As Anna already explained, we have 2 round tables, and on this round tables, we were going to have Dr. Fabrega and Dr. Juan on the first one, but I think we're gonna make a switch right now and start with the second round table that we have already right here. So I'm gonna leave you again, and thank you so much, everybody, for staying with us. And we apologize for the inconvenience. So Anna will just switch the tables and present the rest of the speakers. Thank you so much.
All right, let's try once again. Good evening, everyone. In this occasion, in the second roundtable, the topic that will be addressed is towards a sustainable balance between critical infrastructure and terrestrial ecosystems, Sustainable Development Goals number 9 and number 15. The methodology that will be used for the organization of this roundtable will be the same as the previous I explained before. First, each expert will have from 5 to 10 minutes to make a short presentation related to the central theme of the table. Later, we will have a question and answer period where the speakers will answer questions from the public. These questions can be left in the YouTube chat during the presentations. Finally, we will have some conclusions from the speakers. To begin this roundtable, our first expert is Dr. Francisco Grajales. He is a professor and researcher of geotechnical engineering at the Technological University of Panama. Dr. Grajales obtained his undergraduate degree in civil engineering from Technological University of Panama and obtained his master's and PhD in geotechnical engineering at Texas A&M. He is currently a faculty member at the Department of Applied Geosciences and Transportation of the School of Civil Engineering, where he teaches courses at both undergraduate and graduate levels. He is also a principal investigator on several research projects funded by the National Secretariat for Science, Technology, and Innovation. Finally, he is the head of the Applied Geotechnics Research Group of the School of Civil Engineering, where he develops research on geotechnical engineering and its related areas. Please welcome Dr. Grajales.
All right. Good evening, everyone. I'm hoping you guys can see my screen and we have no technical issues since we are here in Panama as well. So before starting, I would like to give a special thank you to all our guest speakers, Dr. Schwab from Texas A&M University, Dr. Xiaobin Chen, and Dr. Yuan Xiao from Central South University. It is truly an honor to share this space with you, and I truly hope we are able to find common ground and be able to build upon this meeting, build synergies for future collaborations. So a bit about my presentation. So the topic of the roundtable is towards a sustainable balance between critical infrastructure and land ecosystems. And I'm going to be truly honest with you. I'm a geotechnical engineer, and sometimes for us geotechnicals, it's a bit difficult to think about land environments. We are involved more in the construction of civil projects. So my challenge after this meeting is to find out a way to be able to work on both topics, infrastructure and ecosystems. So a bit about the content of this presentation. I'll first introduce the Sustainable Development Goals from now on, SDGs, number 9 and 15, for those who are not familiar with them. Then I'm going to speak a little bit about the priorities in Panama to create basically a framework of what are the needs that we have here in the country. And then I'm going to present the current projects that we're working on. There are actually 3 projects that have been funded, and we're working on them and see how they fit into these sustainable development goals. And finally, present some ideas for future work. Some of them we already started working on. Some others they still need to we need to think a bit about them before formally starting on them. So first of all, we are talking about Sustainable Development Goals 9 and 15, which as we can see on screen, number 9 refers to industry, innovation, and infrastructure. And number 15 is life on land, as we translate it in Spanish, terrestrial ecosystems. That's, if you look at the UN site in Spanish, it would say that. And one thing that we have to say about these goals is that the objective of the SDGs is to promote prosperity, right, while protecting the environment, right? So the UN, the United Nations, when they created these goals, they identified the fact that we have basically overpowered world's nature right? And we need to learn how to redo things in such a way that we can go together with nature. And as such, we cannot think about these two goals as separate topics, right? They are all interconnected, as you're going to see through my presentation. And I'm pretty sure as we move on to the now table number 2, which is related to water, with Dr. Fabrega and Dr. Wan, they're going to talk about goal number 6. But there's really a deep connection between all of the SDGs. Think about water, for example, and infrastructure. One of the main elements we use for infrastructure development is concrete, right? And water is an essential part in concrete mixtures. So a bit about the goals. We have goal number 9, which aims to build resilient infrastructure, promote inclusive and sustainable industrialization, and foster innovation. And this information, you can find it in the UN's website. And it says we should aim to fund projects that provide basic infrastructure, such as roads, water, sanitation, and electricity, right? In both of which are, all of them scarce elements in some of the developing countries. So when we speak about infrastructure and we look at this goal, we have to come up with the realization that they are talking about critical infrastructure, right? So that type of infrastructure that is needed for the country to be able to function, right? In many other literatures, we call these lifelines, right? And now, looking into SDG number 15, which is the one that at least here in my group we fall a little bit short on, is to protect and restore and promote sustainable use of terrestrial ecosystems, manage forests, combat desertification, and halt and reverse land degradation and the loss of biodiversity. So it, for us here, at least from the geotechnical perspective, right, the challenge is to incorporate this goal number 15 in some way or to some extent every time we think about geotechnical solutions, right? And we're going to speak about this at the, towards the end of the presentation. So, said that, let's take a look at what are the priorities in Panama, at least related to, the framework of this presentation. We have 2 slides on this. The first one is the National Policy on Science and Technology, which is a plan that is basically made with 5 years in mind. So the one we have right now runs from 2020 up the way until 2024, right? And they have identified 3 main components. They say we have environment, we have water, and we have energy, right? And they go ahead and detail. They say, well, environment, we have deterioration on several regions of the country. We need integration of R&D for topics related to the environment, coordination for problem solving, and then we have lack of infrastructure and human resources. And that's a common denominator for all of the identified areas. Now, when one looks at the Panamanian policy for science and technology, you may say, well, infrastructure is not here. And well, it's not true. In reality, it is. It is there, right? Every time you think about water, as we're going to see here, for example, lifelines or one type of lifeline is the water supply network, right? And that's a type of infrastructure. So there's a deep correlation between these sustainable development goals that, at least here in Panama, we need to think about all of them every time we want to start a new research endeavor. Now, the other plan that we have here in Panama is very well aligned with the United Nations SDGs, right? And it does give us a little bit more leeway when we want to think about how to solve a problem, right? And the problem is not necessarily, let's say, water. That is a well identified necessity in the country. But if we deal with something that has to be with water, and then find a way to to solve other problems at the same time, then we have a project that is very attractive for policymakers. Now, with that brief introduction about SDGs and the reality here in Panama, the priorities that we have, I would like to move on to speak a little bit about the projects that we're developing here. So the main project that we are working on in my group is the entitled Seismic Vulnerability of Drinking Water Supply Networks in Panama. And here we collaborate with a wide range of specialists, right, of people who are going to work on different aspects of the research. As you can see on the title itself entails a wide range of engineering branches. For example, myself, I take part of the geotechnical. Dr. Pinto, she's in charge of the vulnerability analysis. Dr. Mojica, seismic. Dr. Munoz, water management, and so on. Now, one of the curious things here is that as we were writing this proposal, we thought, well, we're going to apply to a research project on SDG number 6, right? And as we finished writing the proposal and we were developing the project, we realized that we are also, in some ways solving issues in infrastructure, right? And more specifically, thinking about sustainability, right? Sustainable cities. Because the objective of the project, right, is to identify the seismic potential for seismic damage and the associated risks in different cities around the country, right? Taking into account several components, right? You call it structural, geotechnical. We have social components. We have, I'm trying to think out here, economic components, and then come up with a vulnerability formulation that is, adequate for the country, right? So as I was mentioning here, it's a very complex project. We are actually in the early stages. So all of the projects I'm presenting today are on early stages. So we don't have actually results yet, and we have been severely affected by the pandemic. So the components of the project, as we can see in the left picture on the left, we have the hydraulic component, which entails identifying materials on pipelines and running hydraulic simulations, seeing how the system behaves in case of localized failure or a general failure of several of the main pipes. Then we also have the geophysical component. We can see here in those two pictures, right? This is one of the main pieces of equipment we were able to acquire with the project is geophysical prospection equipment. And what we plan on doing with this piece of equipment is to monitor the propagation velocities on the soil to give us an idea of how much are they and be able to correlate them with other properties of the soil, right? And with that data, we're going to be able to develop what we call a soil structure interaction analysis, or in this case, a soil pipeline interaction analysis to then be able to assess how a movement in soil, right, or how the correct term is an acceleration, right, is going to affect the pipeline. As we can see in the picture, many of them undergo different deformation modes, as local buckling, ovalization, depending on the direction and nature of the stresses, right? So this is just to mention some of the components, and as you can see, the whole idea is to, once we do all of these, be able to generate a more complex risk analysis framework. Now, project number 2 we change gears completely, and then we talk about energy, right? We have the project entitled Characterization of Tropical Soils for Low Enthalpy Geothermal Energy Applications. And in this project, I am co-PI, so the principal investigator is the student. Here in Panama, we have this type of projects where the student is able to empower themselves as PIs with another responsible faculty member, in this case, Professor Guadalupe Gonzalez. And as you can see, again, the common denominator between these projects here in Panama is that you have to deal with several of the SDGs, right? Obviously, the main one here is energy, as we are trying to find sustainable sources of energy, but also we are innovating on the infrastructure, right? Working on sustainable cities and taking climate action, since we're reducing the CO2 emissions, right? And the whole idea here is what we call energy piles, commonly, right? We have a diagram here that shows that the foundation is part of the structure that we need, right? You need to use it for support of the structure, and then the idea is, why don't take advantage of that and, use the foundation as a heat loop, right? Or a heat exchanger, to be able to inject or harvest heat from the soil, right? And some people, at least here in Latin America, are still skeptical about this, but we know that the technology has been successfully used in other countries. An example is here. This is terminal at the Zurich airport. The terminal has 400 pile foundations, and 300 of them are energy piles, which accounts for, most of the energy used by this terminal, this building. And again, we have this project, and this is the third one, reuses of plastic waste for unpaved rural roads. And as we can see, we are in the geotechnical realm, but we range. Geotechnical is a very wide area. And I want to use the opportunity here, since the students here, Ana Boyd, Orlando Leiva, Dariana Martinez, Monica Flores, one of them is our moderator right now. So I would like to kindly ask our tech support if she's able to let my student, Ana Isabel Boyd, be on the audio to be able to explain this slide.
Good evening. Can you hear me? Yes.
Yes.
Okay, perfect. This investigation project began as a mandatory classwork assignment that my classmates Monica Flores, Orlando Leiva, Dariana Martinez, and I developed last year for our soil mechanics course under Dr. Grajales' supervision, to be presented at an event called the Scientific Initiation Day. After ending as finalists at the National Scientific Initiation Day, we submitted the project idea to Panama's National Secretariat for Science, Technology, and Innovation, which was accepted and is currently in its early stages of initiation. Our aim is to evaluate the feasibility of reusing plastic from bottles for the manufacture of geogrids with suitable properties to be implemented on unpaved rural roads. Under 5% of collected plastic waste in Panama is recycled, so reusing this resource could be a more feasible process. Throughout the Republic of Panama, there are more than 4,890 kilometers of unpaved roads, which are not always properly reinforced, since their construction is often temporary and the investment of reinforcing material is not justified for a road with a useful life of approximately 1 year. Gravel roads can be easily ripped by the formation of grooves or depressions that are produced by the repetitive passage of vehicle tires on the road. Strengthening unpaved roads by using plastic geogrids could improve performance and increase the life of such roads, as well as to protect the safety of those who travel on them.
Okay, well, I'm guessing that's the end of the explanation, and I need to add nothing else to this, just point out to the fact that, once more, this project inherently touches 5 Sustainable Development Goals. And as a result of that, it's has been widely accepted in other venues for presentation. Right now, it has been accepted for poster presentation at the U.S. National Conference on Undergraduate Research, which is going to be held virtually this year. And once more, the common denominator between these three projects is that you have to deal, or at least here in Panama, right, to be able to develop research with CENACID, which is our equivalent to the USA National Science Foundation, right? You need to solve several problems. You need to attack several problems to be able to get the funding. Now, future work. We only have 2 slides left. One of my, I want to say my favorite topics, it was my doctoral topic, is laterally loaded piles. It is a topic that obviously is difficult to link with SDG number 15, but nevertheless is a need that we have in our country and worldwide, right? You may think when you see the building, you may say, well, it's a tall building, it's beautiful, but what lays underneath of the building is what really supports the structure, right? And at least in our country, we don't have a well-defined framework for this analysis, basically because it's very costly to do so. And the other topic that I find interesting to delve into, and we kind of started talking about it, but we haven't yet tried to get funding for it, is what we call, at least in geotechnical, we call it soil bioengineering and biotechnical, in this case, slope stabilization. And the whole idea here is to find a way to put together our geotechnical solutions with the ecosystem, right? So to put a practical case to our audience and viewers, one of the most common cases here in Panama is when you have to do a riverbank protection, right? It's something that may have to be done many times these days, since we had 2 hurricanes hit us a little bit hard in some of the country's regions, right? Now, the most common idea is to say, well, let's use some gabion walls and put them together, stack them, and ensure stability, and that's it, right? Well, when you think about it and you look at other countries, for example, at the USA, they have the USDA manual for river protection, and there are options in which you can combine a simple gabion wall with plants and create a micro ecosystem that could serve as a buffer region. So that's another idea that we have in mind. We have done some minor research on this, but still need to delve into it. And with that, we are done with our presentation. And in case there are any questions, I guess this is going to be at the end of the work table. Thank you very much to everyone.
Well, thank you very much, Dr. Grajales. Now we will continue with our second speaker for this work table, which will be Dr. Schwab, with their presentation entitled Magnesium Phosphate Cement for Rapid Soil Stabilization. Dr. Schwab received his undergraduate degree in chemistry mineral engineering from Colorado State School of Mines and his PhD in soil physical chemistry from Colorado State University. His general research focus is remediation of contaminated industrial sites and, most recently, development of sustainable construction materials. Working alongside civil engineers, chemists, material engineers, and construction scientists, Dr. Schwab and his team have been developing alternatives to Portland cement that use indigenous materials, such as soils and binders with low carbon footprints. Applications of his research include soil stabilization and rapid roadbed establishment and construction during extraterrestrial exploration. Please welcome Dr. Schwab.
Thank you very much. It's a great privilege being here. I can't tell you how pleased I am at the invitation, and it's a rare honor for a soil chemist to be presenting at an engineering conference, so I do feel honored indeed. As was mentioned, the topic of my discussion will be looking at some of the alternatives to Portland cement that we've been developing with an eye on a more sustainable approach to soil stabilization, particularly rapid soil stabilization using magnesium phosphate cements. As a bit of a background, magnesium phosphate cements have been in place for quite a while. They've been used mostly as a very rapid way of patching cement roadways and sometimes runways. A deep pothole in a runway is a real problem and needs to be rapidly fixed, at least on a temporary basis. Magnesium phosphates work very well because they bind very, very quickly in a matter of minutes, depending on how they're formulated. However, using magnesium phosphate cements as a soil binder is something that's new and has not been pursued at any great depth. The advantage to this is that the high strength and rapid curing would make it possible to stabilize some of these soil materials under emergency circumstances such as flooding conditions when a soil berm needs to be reinforced and so on. Now, give you an idea of the chemistry behind this, the magnesium phosphate cement is the product of acid-base reactions between magnesia or magnesium oxide and sodium or potassium phosphates. The highest strength material made from this reaction would be the potassium struvate. It's a result of the magnesium oxide reacting with potassium phosphate and water to compose the magnesium phosphate. And it's a highly exothermic reaction and proceeds very rapidly. We'll talk about that in just a moment. A general sort of look at the chemical structure is given off to the right. You can see that it's somewhat complex. All the dashed lines indicate all the hydrogen bonding that's occurring within this lattice, and it is quite strong. We'll talk about some of its properties here in just a bit. Now, the rationale of using these cements from a sustainability basis is that these magnesium phosphate cements as binders for soil will leverage the use of local materials. As was mentioned in the introduction, this will include some indigenous soil, so you don't have to import things. Sand can become unnecessary if the soil has the right composition. Also, the magnesium phosphate cements have a reduced carbon footprint. They don't emit nearly as much carbon dioxide during their production. And this is partly because of the much lower temperatures that are used during the calcining of the magnesia. In formation of some of the precursors for Portland cement, much higher temperatures are used. There's tremendous amounts of carbon dioxide that are emitted during this process, as well as the amount of energy that's expended that also ultimately results in the expense or the emission of CO2. Now, in addition to emitting less CO2 during its production, magnesia can also absorb CO2 to form carbonates and hydroxycarbonates after its formation without weakening, which is a very large benefit in many ways, excuse me, when it comes to sustainability. Some of the positive properties that we look at that make it very attractive are the rapid curing and long-term strength. Curing can be on a matter of minutes with the proper additives. However, it can extend to a little bit longer than that, but high CO2 fixing capacities was just mentioned, and then bonding with pre-existing concrete. So this is why it's an excellent patching material. But also, because of its ability to bond with pre-existing concrete, also means that it can bond with soils that are in place as well. So the objectives of this overall research project, which has been in place for several years and is continuing forward, is to test various magnesium phosphate cement matrices and formulations, excuse me, tested on different soil types from all over the world, look at a range of magnesium to phosphate ratios as well as water to solid ratios. Ultimately then to test for strength at various curing times, and to explore the mechanisms of interactions between the cement products with soil minerals. To approach this last objective, we've been using thermodynamic and molecular modeling. This has been sort of new, particularly on the molecular side for us. And then look at some of the spectroscopic examination of the soil to look at the various specific things that are forming in the soils during the setting of the cements. Give you sort of a generalized approach that we've been taking to these cements is that we start out with a very specific magnesium oxide. This is something that we found out early on, is that not any magnesium oxide will do. It has to be calcined in a very specific way. It doesn't have to be particularly pure, but it does have to be heated to an exact temperature. So it's calcined in a multiple hearth furnace to give the compositions that's necessary. It reacts with any sort of industrial grade dihydrogen phosphate. Sodium phosphates are an alternative, but they are less effective than the potassium phosphates. Metakaolin is sometimes used. This adds expense to the process if it is used, but metakaolin provides an amorphous material that bonds very rapidly. It's partially calcined kaolinite. So it also is heated at elevated temperatures to partially break down the kaolinite into some amorphous products. And then finally, the last additive that I show here is boric acid. Boric acid is used to retard the setting of the cement. The curing times are so rapid that in the absence of boric acid, the cement can set up even before you get a chance to pour it. So it's very important to have this component involved. Now, to give you an idea of the kind of composition that we've been using, this is just an example. We see that there's by weight or mass, there's 11% magnesium oxide, 22% monopotassium phosphate, or a 2-to-1 ratio between the phosphate and the magnesium. 18% of both amorphous silicates, that could be the metakaolin or other sources, and soil. 28% water, and then 3% boric acid. And I'll give you an idea of some of the results that we've been getting from this, just to sort of walk you through the kind of results that we've been getting and the direction we're going with the research. The figure on the right is giving you an idea of some of the impact of the water to soil ratio, that's the W/S ratio, of the materials that we've been testing. Various curves that we've been getting off of compressive tests, a typical engineering compressive test where we build some small soil columns of the cement, subjected to a large amount of pressure on the top, and measure the stresses as the soil starts to fail. And the curves that result from this are indicative of the kind of stresses that it will accept, and interpretation of these curves will give us the strengths involved. We'll just kind of walk through the curves here very briefly to give you an idea of what we're facing and some of the challenges that we've been addressing. The very lowest curve here, the yellow colored curve, sample number 4 is a 0.3 water to soil or water to solids ratio. This is a water-starved material. There's just not enough water to make the reactions complete. And as a result, it's fairly weak. Just adding up to 0.4 water to soil ratio increased the strength tremendously. The compressive strength became very high. And if we go to higher levels, we see that the strength falls off again. So we do see an optimum water content for the formulation used in this case at about 0.4. The asymmetry of these curves is indicative that these materials tend to be brittle. So they take a lot of stress in the beginning, but once they start to fail, they do fail quickly, as shown by the steep curves shown here. These two bar graphs give you an idea of the compressive strength and elastic modulus that we've generated from some of these examples that are shown in the curves above. And you can see that the compressive strength is good. It's not the same thing as Portland cement, but it does quite well considering the amount of actual soil that's in this composition. We'll talk a little bit more about even increasing the amount of soil beyond that. And the elastic modulus also reflects the brittleness of this material. We've been approaching the problems with the brittleness by adding some organic fibers to the mix. Again, this could be any sort of organic fiber. We've used jute fibers from just made from rope, or we can use some of the carbohydrate materials from growing crops in the region as well. We've tried all of these. They all seem to work in the same sort of direction, giving a little bit more flexibility to these columns and getting away from some of the brittleness. Sort of getting in at a different perspective of this, we're looking at some of the scanning electron micrographs of the materials that we've generated. Just going to walk you from left to right across these figures, just to give you an idea of what we're finding out from looking at these very highly magnified materials. So the magnesium phosphate cement without soil is shown on the left. The upper micrographs are all at lower magnification. Those below are up to as much as 35,000x on the magnification. And as you can see in this lower row, on the lower left-hand box here, that the shape that we're seeing here is very, very typical of struvite. It has sort of a hollow structure to it, but it's very, very strong. When we add soil at the 0.5 water to solids ratio, and keep in mind this is an excess of water, the morphology changes quite a bit. We see that the presence of the soil changes a lot. The addition of the water allows the struvite to be more extensive in its growth. And we're at the optimum water to solid ratio of 0.4, there's even more of this structure involved. We still see the characteristic struvite, but it becomes more intimately involved with the matrix. And then when we get to a very water-starved situation, we don't see very much of the struvite forming at all, and that's a big reason for the lack of strength. So this is giving us some clues about the directions that all of this is going in terms of the chemistry involved, the engineering that's involved. And we would like to take, and as we go forward with this, again, with an eye on sustainability and using local materials that are not being depleted but actually can be recycled. We would be determining the water resilience of the MPC stabilized soil. And in the case of a stabilized soil, we would actually be doing some superficial mixing of the MPC cement into the soil at a very low ratio, just to give stability to these materials. But the water resilience is really key, because if it's not water resilient, then it's of very little use to us. But we've seen some very encouraging results from this early on. We're testing soil to binder ratios and looking at the changes in strength and elastic modulus with other additives as well. I mentioned the fiber. There are others that we're looking at also. Looking at some of the bend tests and other indications that would allow us to get away from some of the brittle behavior of this material. Also, we'll be looking at some more of the advanced spectroscopies to get quantitative microstructure development analysis, and also correlate to some of the experimental strength tests. We would really like to have a strong correlation between the chemistry, which is what I love to do, and the engineering aspects of this. And then finally, we're also looking at the dissolution reactions of the magnesium phosphate cements and weak acids and bases to try to get an indication of the reaction kinetics. This will give us the ability to project forward and get a good indication of how durable this material may be. Anyway, it's been a pleasure to give you this very brief overview, and I look forward to answering any questions you might have at the end of this session.
Thank you very much, Dr. Schwab, for your excellent presentation. Next, we will have Dr. Xiaobin Chen with his presentation entitled Analysis of Shear Dilatancy of Railway Ballast and Rubber Fiber Composite Aggregate, Influence of Rubber Fiber Stiffness. Professor Xiaobin Chen immigrated to Changsha in the Hunan province to hunt his knowledge and experiences when he was 17 years old. Within 10 years, Dr. Chen successfully earned his bachelor's, master's, and PhD in Central South University. His PhD in road and railway engineering has shaped his background on railway infrastructures. During his first four-year career, Dr. Chen observed two postdoctoral positions on the research topics of geotechnical engineering. From 2014 to 2015, Dr. Chen moved into the civil and environmental engineering of the University of Illinois at Urbana-Champaign. Transportation geotechnics, coarse-grained granular soil, and DEM simulation were his research topics as a hard-working visiting scholar. To deepen his expertise on coarse-grained granular soil, he shifted into a distinguished group at Civil and Environmental Engineering, Pennsylvania State University, as a visiting professor again in 2020. Investigating more than 20 years, he has accumulated knowledge for his geotechnical engineering career. Please welcome Dr. Chen.
Hello, good morning. I should say good afternoon because in my time zone it's morning. So forgetting my boring bio is less boring. And thank you for the University of Technology of Panama, and thank you for Evelyn, and thank you Anna to hosting our conference. I think this is a very good platform to make friends and new professors. For example, Professor Paul give us some information about how to absorbing the CO2 in the cemented soil. That's very interesting. So today I will introduce myself at first. I came from the Central South University, located in the Central South of China, so we call it Central South University. I work in the National Engineering Laboratory for High-Speed Railway and the MOE, the Ministry of Education Department Key Laboratory of Engineering of Heavy Haul Railway. So I'm the guy belonging to the railway geotechnicals. So this is our international joint research group, and I work with the other three professors together. And today, because our topic is about the sustainability and renewable and reusable materials today, so I talk about use the polymer fiber used in ballast, and I use the DM as a tool to investigate some mechanisms about these materials. So my topic is that analysis of shear dilatancy of real ballast and rubber composite aggregate. And I will focus on the rubber influence of the rubber stiffness today. First of all, I will show appreciate to three of my students, and Dr. Zhang and Mr. Yang, and especially Abby. Abby is the student is one of my international students, and we are supervising with Dr. Francisco together. Abby is a really smart student, came from University of Technology of Panama. So, and as we know, the ballast consists of so many discrete aggregates together to support the railway loadings. And under the dynamic loadings and the degradations happens occasionally. So we want to find some solutions to resist the degradation and so many years. And one of the traditional way use the degrade, and we want to find a renewable and sustainable and recycled materials such as the fiber polymer wasted polymer fiber to reinforce the ballast, especially at the shoulder of the ballast. And because we know the ballast have some shortcomings on the shoulders, and sometimes it's a failure as in the dilatancy style. So today, and we want to find some renewable, recyclable materials, such as the used tire, and to be cut it into strip as a polymer fiber. And we have finished several research works on this topic, and we have finished several dozens of large-scale monotonic exercise, and we find that the optimum value by the polymer fiber is between the bivalent is 10 and 20% bivalent. And as we know, there's a different parts in the used tire. On the face of the tire, it's reinforced with the steel wire, and in the inside of the tire is reinforced with the polymer. It's for example, it's linen. So it is very clear there's a different. There's quite a difference in the stiffness on the surface of the used tire and the inside of the tire. So I think that we should know the difference in the stiffness story behind the polymer fiber and aggregate mixtures. And so today I want to use the DEM method to research on the effect of stiffness of the polymer. So we divided the materials into the segregate elements with the DEM, and we in the DEM we think about the real particle shapes of the ballast, and also we use a flexible boundary to simulate the membrane in the triaxial test. And we use the 3 bound model to simulate the triaxial test. And this is the parameters of test here, and we use the relative stiffness, and we call that the ratio of the fiber to the aggregate particles. We use here we use the G particles as there's a 1 million centimeter and 100% and 10% and close to the G particles. So this is our simulation process, and we got some from the DM. We got some stories behind the test. And as we know, when the higher stiffness of the fiber can increase the peak strength, that is clear in our result. And the other story is about important that the stress and the strain curves tends to be a strain hardening type with the under the lower fiber stiffness. For example, this when the stiffness is about one multiple 5/10. It's a strain hardening type here, and with a higher fiber stiffness, it is totally changed. There is a strain softening in the stress and the strain curve. So I will tell you some specific informations behind this kind of story. And as for the volumetric strain is the same, and so I want to share some stories behind this phenomenon. And we used the Bolton defined dilatancy friction dilatancy angle, and the bottom dilatancy angle will increases with the increase of the fiber stiffness. That means if the fiber stiffness increased and the dilatancy will be developed. And for the average coordination number, and what's the average coordination number? That means there's if they have a fiber aggregate, then how many how many aggregate particles will connected with one fiber atoms? That is the average coordination number story. And with the increase of fiber stiffness, the average coordination number decreases. That means that the dilatancy increases. That means if the stiffness of the fiber is too higher, maybe the more failure will happen at the ballast shoulder. So, and we also get this very specific story of the particle movement and, for example, the rotation. And we got this rotation story with the rising of the fiber stiffness, the rotation angle of the grid particles. Here we means the ballast connecting with the fiber particles increases, and that means when the fiber stiffness is rising, then the rotation nearby the fiber will increase. That means company with the dilatancy development, the company with the strain softening sharing behavior, and with the dilatancy angle increasing. So we also use the contribution ratio to explain the dilatancy happenings, and we find that here as the fiber stiffness increases, the G and G contact. That means the particle, the aggregate particle contact contribute the increase. That means the particle, the aggregate will support more to resist the traffic loading and the railway loading. And then we move the internal tensions of the fiber, and we find that with the increase of stiffness, the average tense force of the fiber will increase. That means if the stiffness increased, the fiber can support more forces from to resist the traffic load. So here I want to go very quickly to my conclusions, because I only have 5 minutes to share my story. So we got some very specific on the fiber stiffness, on the dilatancy of this kind of composite. I think we think the fiber stiffness is relative when the fiber stiffness is relatively large. That means close to the ballast particles, it will trigger the dilatancy developing, and that's not helpful for the ballast shoulder stability. And the second, with the increase of fiber stiffness, the average coordination number decreases. That means the dilatancy increases, as well as the rotation angle of the particles, and the aggregate particles contact decreases. So I think this is my story of about the fiber aggregate composite in the meso scale dimension. And to do this kind of research, and our aim is to hope to prevent the Chinese government, the Chinese railway company to use this kind of recyclable material to settle some real problem in the ballast railway and to get a sustainable development. Our next work will be focused on the dynamic loading triaxle to know the effects of size ratio and the rubber content on this kind of scale. Maybe we will conduct some full-scale model testing in this December. So that is my story, and thank you for everyone, and thank you for University of Technology of Panama, and forgive my boring bio and forgiving my limited English. Thank you very much.
Presentation.
Yeah.
Next up, we will have Dr. Zhuanjui Xiao, also from Central South University in China. Dr. Xiao holds a bachelor's degree from Tongji University and a master's degree from Southeast University, both in civil engineering, and another master's in theoretical and applied mechanics and a PhD in civil engineering from the University of Illinois at Urbana-Champaign. He joined the faculty of Department of Geotechnical Engineering at the Central South University School of Civil Engineering in November 2014. Since August 2008, Dr. Xiao has been an active member of the International Association of Soil Mechanics and Geotechnical Engineering, American Railway Engineering and Maintenance of Way Association, the International Society for Concrete Pavements, the ASCE Engineering Mechanics Institute, the ASCE Geo Institute's Pavement Committee, and the American Society of Mechanical Engineers. Dr. Xiao is also an affiliate of the Transportation Research Board and has actively participated in several TRB committees. He has research interests and expertise in testing and modeling of pavement and railroad track geomaterials, such as base ballast unbound aggregates, recycled aggregates and their unbound applications, shape, texture, angularity characterization of aggregates using video imaging techniques, modeling of particulate media using discrete and finite element methods, and mechanistics-based pavement design. Please welcome Dr. Xiao.
Hello, everyone. Good morning. Can you all see my slides?
Yes, we can see them.
Okay. Thank you very much for inviting me to attend this great event. It's my really great pleasure to join you guys. And today, my presentation, I think, is in line with Sustainable Development Goal number 9, life online. So I'm going to present forensic analysis and numerical simulation of a catastrophic landslide, which occurred in China several years ago, due to the combination of dissolved and flux rock masses with underground mining. And as Anna just introduced, I'm from School of Civil Engineering, Central South University, China. In the next 5 to 10 minutes, I will quickly present the following parts. First, I will quickly introduce the background of the problem, and then I will introduce some forensic results and also some discrete element modeling simulation results. So here is a quick introduction of the catastrophic landslide event in China. This happened in a remote mountain area in China, and at that time that was kind of like a very catastrophic event with 490,000 cubic meter debris generated, and the kinematic energy of the collapsed rock debris was so great that the travel distances were beyond 600 meters. Therefore, it caused severe life losses and property damages. And that's I have a short video to show at the end of my presentation, just let you to see how serious the landslide was. And as an effort to do some forensic analysis, we were able to identify some possible causes of this landslide, which includes intrinsic geological conditions and underground coal mining. Actually, the focus of this presentation was on the discrete element simulation part. First of all, let me briefly introduce the geological and the topological conditions in this event. The landslide is located in the karst regions, which means rock masses are very susceptible to dissolution and fracture. And the geological formation of the landslide is unique with very high elevation differences. So after some field investigation, we found out that the mountain had very hard up layers and very soft lower layers. There were two primary joints in the collapsed rock masses, so which means the rock masses are cut by such two primary joints. Another thing which was, very interesting, it was that there were staged coal mining operations under the bottom ground of the collapsed mountain, which means we also have to pay attention to the underground coal mining, which might be one of the triggering factors. And the intrinsic courses includes, the geological formations, topological features, and degraded rock masses, which means the rock masses are relatively disintegrated due to the harsh environment. Uh, Here is some photos we took in the field. As you can see, here is at the top. That's the initiation area of the landslide, and there are some close-up pictures of the rocks. As you can see, they have some dissolved pores and also have some, fractures going on and the travel distance of the rock debris is so high, so great that they even damage some coal mining facilities at the bottom of the mountain. Okay, so as you can see, regarding the coal mining operations, there are three different mines, coal mines, M16, M14, and M10. As you can see from this one, M16 was terminated in 2010, and M14 was active from 2013 to 2016. And M10 was started in 2015 and was active until the date of catastrophe. So here were some photos taken during the mining operations. As you can see at the top, right top, there were some small scale collapse observed in 2009, probably due to the mining operations of M16. And during the mining operations M14 and M10, there were some big cracks observed at the back of the mountain, which was represented in this figure as F1 to F7. Those are the big cracks, and as wide as maybe up to 40 millimeter. So this presentation was mainly about, we want to find out what are the potential causes for this catastrophe so that we can, in the future, come up with some remedial measures to avoid such catastrophe, and also try to figure out what are the real causes for this catastrophe. We consider several factors. So first of all, we have to consider the intrinsic causes, which are the dissolution and fractures in the rock masses, and we also consider underground coal mining operations. So in the numerical simulation part, we break it into several different tasks. So first of all, we analyze the deformation failure mechanism of dissolved rock masses with pores. A second task, we simulated the fracture and the deformation characteristics of rock masses with random distributed fractures. And third task, we combined the previous two. We simulated the rock masses with both dissolution and the fractures. And the final step, I did, the mining operations at the bottom of the mountain. So just to simulate the application of all those different situations and try to understand how the damage will initiate. So I will quickly go over some results from each different task. So at the first task for the dissolved porous rock mass, we collect some field images and use this digital image processing technique, and we simulate the uniaxial compression behavior, and we were able to identify their stress strain behavior and categorize the whole stress strain behavior into 3 distinct stages. And there were some key DM simulation results, as you can see from this force chain network charts. Green ones representation and gray ones represent compression. And you can see, the failure mechanism of dissolved porous rock is mainly progressive skeleton failure, which is governed by the degree of dissolution. And in terms of the simulation of fracture rock mass, we also collect some statistical parameters for the fracture distribution in the field, and then we were able to input those into the discrete element simulation. And those are the simulation results of biaxial compression test of fracture rock masses, and we were able to identify the failure mechanism. As you can see, the vertical fractures, they play a major role in the damage. And the middle one shows the third task. We combined both dissolution and fractures, and then simulated the damage mechanism of such rock masses at a different level of degradation. And here is a DM simulation results of uniaxial compression test at different dissolution or fracture levels. And we also simulated the damage evolution, how the damage evolves with different dissolution and fracture levels. And this is the DM contact force chain for one of the results. And we also did a complete DM simulation with both dissolution, fracture, and underground coal mining operations into consideration. And we also did a model test, very small scale physical model test, just to verify some of the DM simulation results. Here shows some the simulation steps we did. First, we considered the top of the mountain to be very dissolved and very fractured, and then we added into the staged coal mining operations, and then we observe how the deformation transfers and how the cracks initiates and how the collapse initiates, and then compare with the small scale physical model test as well as some field evidence we collected. And this is some quickly simulation results. So we combined the finite difference method and the discrete element method to complete this numerical simulation. and we were able to we were able to obtain some correct characteristics from the DM simulation, and they overall agreed the findings from forensic field study. And here are some results from the physical model test. The collapsed area from the physical model test, they kind of like matched the observations in the field site. And the rest are some the remaining results from the numerical simulation. We just try to understand for the collapsed zone, or for the locked debris from the collapsed zone, how they move, and what are their kinematic characteristics, so on and so forth. Okay, so in summary, so we did a forensic study for a catastrophic landslide event in China, and the main goal was to understand, what factors caused such event. And in the future, we are going to continue working on, how to come up with some remedial measures, either to reinforce the mountain, or or to reinforce the coal mines, and to avoid such catastrophic failure in the future. So those are the main goals of this study, and we hope that by this effort we can address the sustainable development goal number 9, which is to save lives on the land. Thank you very much, and I will just, if possible, I will just play a short video about the event, so that you can get an impression about what I just said. Just give me 1 second, please. I hope you can see the video now. Okay, thank you very much. That's all my presentation, and look forward to have discussions with you at the end of the session. Thank you very much.
Thank you very much, Dr. Xiao. We will have a change in our agenda due to some circumstances that we've had. And instead of having the question and answer session, we will move on to another presentation. This presentation is actually from the next work table, which has the topic Integrated Management of Water Resources and its Importance in the Fulfillment of the Sustainable Development Goal number 6. Our first speaker about this topic is Dr. Jose Fabrega. Dr. Fabrega has more than 20 years of experience as a researcher in various areas of environmental engineering. Recently, he has focused his efforts on issues related to the water and carbon cycle, river basin management, and climate change. Dr. Fabrega obtained his civil engineering undergraduate degree from Universidad Santa María la Antigua in Panama. Later, he obtained a master's degree and a doctorate in civil engineering with emphasis in environmental engineering from Purdue University, Indiana, United States. He has been a principal investigator and a co-investigator in multiple research projects funded by the National Secretariat of Science, Technology, and Innovation of Panama, the International Atomic Energy Organization, and the Cooperation Agency Japan International. Dr. Fabrega is currently the interim director of the Center for Hydraulic and Hydrotechnical Research of the Technological University of Panama. In 2019, Dr. Fabrega was appointed a member of the Global Water Partnership Global Steering Committee, and in 2020, he was elected president of the Panamanian Society for the Advancement of Science. Please welcome Dr. Fabrega. Dr. Fabrega, I think your microphone is muted.
Yes, if you can go on and up the presentation, please, that I asked for.
Okay, our support team should put it on display.
Yeah, just give me 1 second.
Okay.
I'm just making sure. There you go.
Okay, good afternoon and good morning. And we have in different sometimes. I will talk a little bit about an introduction to what the relation between integrated water resources management and its important in the fulfillment of the HDD, the sustainable development goals. We are going to focus a little bit on number 6, that is clean water and sanitation, and talking about the case of Panama. There are 17 sustainable development goals. Each of them has 8 targets. These goals are kind of, they went after what something else that was called the Millennium Development Goals that were set by United Nations at the beginning of this century. And then in 2015, there was this effort to come with these sustainable development goals. The main difference between these two is that the Millennial Development Goals of 2000 were set by the United Nations, mostly to developing countries. The Sustainable Development Goals were more of a working group that create these with targets. Each goal has a certain a number of targets, and those targets are for the year 2030. This is a very important effort, since try to focus everybody, try to focus all countries, not only the developing country, but also rich countries and poor countries. Every country has to work on try to put everybody together to focus on these goals. And the main objective at the end is to having a more prosperity, but also taking care of Earth, taking care of the planet. So a sustainability and also economic growth. No? The next slide, please. Those are the 17 goals. The one we are going to focus is on clean water and sanitation. These goals are related. Clean water and sanitation, well, at least to me, one of the most, I don't know if one of the most important, but one of the basic ones. Because if you don't have clean water, and sanitation also is a source of inequality. That is the goal number 10. Quality education is very hard to have if you don't have water. There are some countries where people have to basically spend too much time getting water, and that takes time even to young people to concentrate in activities like education. The infrastructure is important too. It's another of the goals that is also related with water. Now, these are the 8 targets. Those are the 8 targets that come with clean water and sanitation. And the important here thing is one of these targets talk specifically about integrated water resources management at all levels, and through transboundary cooperation too, because sometimes there are many watersheds and there are many groundwater sources that are shared by 2 or more countries, and it's important this cooperation in this sense. Next slide. Now, what is the integrated water resource management? And basically, as you can see, the definition is a process, basically. So it's something that is going on, which promotes coordinated the development and management of water, land, and related resources in order to maximize economic and social welfare in an equitable manner without compromising the sustainability of vital ecosystem and the environment. As you can see, they are very aligned with the SDGs. The basis of IWWRM is that water users are independent, so everybody has their own necessity for water, and the water resources are finite. I mean, you don't have infinite amount of water, and that is the basic of it. So IWWRM aims then for a good communication between all sectors, and for that you need a good governance. That means also a strong institution. You need transparency. You need policies that are inclusive, in a sense that everybody can participate, communicate, and then the use of water can be also efficient. No, it's not too much concentrated in one issue. No, next one. In the case of Panama, about 66% of the population live in urban water. There are big inequalities if you compare with the indigenous areas. That is 10% of the population that can go up to 28% of water access. You should see the average of water access of the drinking water in Panama is 90%, and that's the average. But you have about 10% of the population that are in the indigenous areas, where you can go as low as 28%. So when you see that, you see big inequality. That's something that has to be addressed. Also, so since you have a rapid population growth, maybe mainly in urban areas, then it's hard for government to keep a good pace with the construction of infrastructure. No. Even though Panama have 80% of our watershed has a good water quality index, urban rivers, basically in the middle and the lower basin areas, have a bad quality. That's the case of the city of Panama. That's one of the reasons. The water we need to take is the same one that the canal use. The canal use fresh water for the vessels, for the passing of a vessel. No? Also, another good thing we are doing is the Panama Bay Sanitation project that started in 2006 and continue and is supposed to cover 70% of the population of the Panama City population. We are now in stage 2, and it's a project that has lasted a different government. What is good. I mean, it's an state project, and those are the kind of things you want to see in the water infrastructure. Next slide, please. Some proposals to improve the situation in aligned to what is an IWRM. We need a stronger institution, as I said. A water authority will be nice. Right now, you have water fragmented. You have, for example, the Minister of Agriculture has some goals. You have, you have the different institutions having different uses to water, maybe working a little bit not as coordinated as they should be. No, that happened also in the UN. For example, you have different agencies with different agendas for water, and becomes some complicated. So we need a strong institution in the country, need a modern legal framework. The framework we have right now is from 1966, what's called the water law. In a way, we need to strengthen IWRM. Right now in the Panama Canal watershed, we have that, but we need to use that in the other 51 watershed that we have in the country. Infrastructure is also important. No? Now, when I talk about infrastructure, I would like to talk about human resources too. It's important to increasing the education level of the population as the best way to reduce gaps, and also to reduce the rapid population growth, or the immigration to cities that's becoming a problem too. We have a national plan for water security 2015-2050. That is a step in the right direction. However, it needs periodic reviews. With this plan, also was created CONAGUA, that is a committee basically to oversee the advances of all the projects, the infrastructure project within this plan. No, is improved aspect of water treatment and continuity of access. Even though we have 90% of the population has access, continuity, and not in some places there is no 24/7. Greater investment in research and the development of technical capabilities is also important. And other point also is to develop integrated activities. Sometimes we wait too much for the government to do things. It's important the private sector come together with public sector and also to come with the initiative to develop a more efficient way of using water. No? Also, it's important the effect of climate change is something that we need to consider in the future too, and that means also developing adaptation policies and plan accordingly. And with this, I would like to thank you. It's basically a overbrief of the situation, and I will be more than happy in the question and answer section to address some of these issues in a more the deeper way. Thank you.
Thank you very much, Dr. Fabrega. Now we will have our last speaker for the night, which is Dr. Jin Wan from Hora University. Dr. Wan obtained his undergraduate degree in water resources and hydrology at Hora University, China. Later, he obtained a Master of Science in Hydrology at the Delft Institute for Water Education, the Netherlands. Then, in 2003, he earned his Doctor of Philosophy in Environmental Hydraulics at the Swiss Federal Institute of Technology, Switzerland. He has been the Vice Director of the International Office at Hora University since 2007 to the present date. Since 2003, he has had functions as Associate Professor of Hydrology and Water Resources at Hora University, teaching and researching water-related issues and supervising diploma work and graduate students. He also worked as research assistant at the Swiss Federal Institute of Technology from 1996 to 2003 and at the Delft Hydraulics from 1996 to 1998. He also did his lecture in hydrology at Hora University from 1988 to 1994. Please welcome Dr. Wan.
Okay, thank you.
Dr. Wan, your presentation is on screen right now.
Can you hear me?
Yes, I can hear you very well. Thank you so much.
Okay, good. Let me try. Okay, good morning here. I think I should say good afternoon in your side. Now let me try to give the presentation about the topic about the integrated water resource management to achieve, the SDG 6 in China. And you say that I'm from Hora University. I think from our university name, maybe most Chinese, they will know the meaning and also for our role in China. Hora University is the water university. From the name, it's He. He means river in Chinese. Hai means sea, ocean. So the university for study the river and the sea. It means study water problems. Okay, so it's the strongest university for the water education and research in China, and also is very, very famous in the world for the water research. And also we have a lot of students. in our university for water study, and also we recruit more than 1,000 students from outside to study, PhD, MSc, and also the bachelor and graduate studies at Hora University for water. Now I will give you some of the brief introduction about the topic about integrated water system management. So for this talk, we will include several parts. The following part: what first one is about the Chinese, the water resources in China, and second one I will talk about in China. The main one is the water pollution, and also how to do or to achieve the goals of SDG 6 by using the different measures, engineering measures, and also non-engineering measures. And last I will give some of the conclusions, maybe the future works for those studies. The objectives of this presentation is to ensure to access the clean water and sanitation for the SDG 6. This means one want to get the development of the not only for water resources but also for the social and economic development is to be sustainable to achieve the goals. For the SDG 6, I think Professor Jules already gave something about the introduction about the SDG 6. We talk about it because why we talk about the SDG 6? Because it's very important. First one, in China, we say water is essential for the life. And somebody say what is the origin of life? It's true because the most important things for what in the world, on the earth, water is the most important for ecosystems, okay? And also it's very important for the productions, not only for agriculture, but also for industry, and also for other side. This means we should make some grain or food to live. And it's also essential for the ecosystems, for the nature's part, okay? So we talk about water, we should talk about, the relationship between human beings with the nature, between the nature and also with the productions, okay? So here they show that, so SDG 6, it means the clean water and the sanitation is the most important and the best part for the living environment. Why we talk about that? I think in the world we have a lot of water problems. The first, I think, maybe the drought problem, as showing the figures. The drought means we normally talk about water. We have talk about 4 aspects or 4 issues. One is means too much about the water. One is means another one is too little. It means less water. And also we talk about turbidity and also the dirty waters. So it means for the water problem is that the much water it means the floods. The little water it means the drought. The dirty water it means pollution. And the turbidity it means erosion and sedimentation in the rivers and the lakes. So we have the formal, the general problems about before we have the flood and the drought. And with the rapid economic development and also with the increase of the populations, we use more water, we take more water, we demand more waters, and also at the same time we produce more waste, and also goes into the rivers and lakes to pollute the water. And at the same time, for the agriculture activities, human beings, the activity by the human beings also have the soil erosion and the sedimentation in the water problem in the rivers and the lakes, okay? And at the same time, and also we should consider about climate changing, Urbanization in China is, the city, more people move to the city. And the size of the city, I think during the past 20 years, about maybe 3 or 4 times of the city size, especially in our east part of China, okay? If you come to China, you can see that. It's really beautiful city, but sometimes we consider about infrastructure, we have a lot of problems. For water supply, it's okay, but for the wastewater treatment plant, we have less. So we have a lot of problems, not only for the water pollution, but also we have the air pollutions and also soil pollutions. All the three types of pollutions, at last, they will have introduced something, the pollutant go to the water bodies. One is lake, and one is the rivers. Will pollute our water bodies, okay? I think most people know in the world, China is a bigger country, okay? It's a bigger country. We have a lot of water problems, not only for the 4 types, and also for the water is not finite. It's infinite, not infinite, it's finite. It means the water is an uneven distribution in time and space. In time means the water, it means it's not equal for every month. So it's uneven in the time. It's a seasonal variation. At the same time, it's also uneven distribution over the space. In China, South China have more water, and the northwest part, they have less water. And those water problems, water resources, also uneven matching with agriculture productions. It means for the agriculture water use, we need more water, but in this area, we don't have enough water for agriculture purpose. And also, we have a huge amount of water in China in the national level, but we have a high population for per capita volume is very small. It's about maybe 1/6 in the world average level. And the next one is also the variations for the river runoff. It means water resources. It's a big inter-year variation and also intra-year variation. It means the first problem means uneven distribution over the time. And also the inconsistency between the distribution of water resources and the product over the regions. Some regions have more water, some regions have less water, but the productions maybe have more water, they only have the farmland, they can produce not as much as the productions, okay, over this bit. And also big gap between the water supply and the demand in North China, okay? And the next challenge is the low water use efficiency. This is something, the characteristics of the water resources in China, maybe some of the challenge or problems at the same time to appear here, okay? And for the water resources development and utilization in China, we have different phases. We can see here, I show you along the timetable, in the first stage, we separate, in 5 stages. The stage 1 is the basic demand. It means normally consider about the water, you have enough water. Or during that time, the water is clean, okay? Clean, no pollution, okay? And next time we use the water, it means the basic and economic demand, not only for the living use, but also for the economic development, for agriculture, for industry, and for other purposes, okay? The third one is the advanced demand emergency. It includes every part of the demand, the users, okay, users. And the last, they have some advanced demand and also multi-demand. It consists not only for the production, and also we consider about the pollution control, okay, and also for the water resources reform and development, okay, and also not only consider water, but also consider soil conservation. It means we study water. For the water problem, not only the water itself, we should consider the land, okay, the air, and everything, because the pollutant, the particles, they move, the flow, they move at last, go into the water bodies. So we study water problem not only to water directly, we should include the water and also the customs, the environment also. And in China, I think most people know that we have a lot of bigger problems for water, but currently most important problem is the water pollution. In China, there are also 3 famous rivers. One is the Huaihe River, one is the Haihe River, and the Songhua rivers. These 3 rivers in North China. For those 3 rivers, they have a less runoff, okay, less runoff, but they have the high pollution problems in those regions. This is for Huayhe River. We can see the pollutant from the 2004, 2012. I give some the numbers about, we classify the water pollution, the water quality from 1 to 5, and also even worse than 5, we use 6 here. You can from the blue line and the red lines, it means those water can't be used for agriculture use. I mean, the green, it means the good quality, the class 1, class 2, class 3. Okay, the green one is better. But at the beginning, I think 2004, we can say for the polluted water is about more than 40% in the Huayhe region, Huayhe basin, okay? And next one I will show you for Huayhe River. It's also the same problems. We can see all those rivers, the water quality very bad, okay? The quality very bad. And the next one is the Thai Lake, RJ blooms. These pictures they take from the 2007, okay, 2007. And the 2088 also have the same problem, and 2014 also have the problem. So we have a lot of problems for water pollution, not only for rivers, but also for the lakes. For the rivers, I said before, we have 3 rivers, North rivers are seriously polluted. And for the lakes, not only for the Thai Lake, but also include several other lakes, the bigger one and also small one. Another 2 lakes. One is the Tianchi Lake in Yunnan province, okay, Kunming city. Also very seriously polluted. And those polluted water, polluted lake, the water can't be used for water supply and also can't be used for agriculture. And the third one is the Chaohu Lake in Anhui province, also have the same problems. Especially during, from April to November, the lake have the algae bloom problems, so they also can't be used. The water can't be used for water supply and also can't be used for agriculture and also industry use. And as here we show some of the figures about the Thai Lake water quality. From here, why I show that? Because in 2007, 2008, we have the bigger problem for Thai Lake. And also, for water supply for the local cities, we stopped. No water for water supply. And the resident, the people, they go to the shops just to buy, 1 bottle of the mineral waters. And all the shops empty. They don't have enough water for drink, for cooking. So they have big problems, okay, for the society safety. And also we study some of the water pollution control and also restoration about the rivers and the lakes. This is the curve we call Kurzman-Corrin curve. It studies the relationship between GDP and also environmental quality. We can see the curve, they have the very nice shape. This study about the Huayhe River basin, okay, Huayhe River basin. It means have high GDP, they will reduce, okay, the quality become better. But have a small GDP, the environment we know become worse. The critical point is means with the fast development of the GDP, of the economics, the pollution can be controlled, okay, can be controlled. Now we have the significant values. And this picture, we can show you something about groundwater variation in China. Okay, just give you one example in North China. Now here is in Beijing cities. We can see why I want to show you the water quality. We see here in 2012 and 2013, the water quality is very bad, okay, for groundwater, the first point. The next point you can see the groundwater level variations from the different years. We can see in 1950s, they have high water levels, groundwater levels. But in the 2000 or 1999, we can see the groundwater level is very low, okay, very low. From some regions, we can see about 80 to 52. So the groundwater level decreased about 20 meters. So now from this, the variation of groundwater level can see in North China, okay, they have a bigger problem if for the water supply before they take the water from the wells. But now we don't have enough water in those regions. Have a lot of, bigger problem of geothermal disaster also in those regions in North China. It's just one example for Beijing regions. And in North China, from Beijing to Guangzhou, along these lines to Zhengzhou city, you can see the groundwater level decreases a lot, okay, a lot. So in China, we have a lot of problems for water. One is there for water shortage. Another one is water pollution. So we should use integrated water resource management, the tools, okay, to achieve the SDG 6, okay, SDG 6. For the integrated water resource management, IWRM, it was proposed by GWP, okay, GWP. It means we should have used the management instrument in involving environment and also institutional rules to do the management. This management are based on the equitable and efficient management to achieve the sustainable use of water resources, okay, water resources. And also we should use some of the technical tools, education tools, and also policy regulation. Different tools we can achieve at the last to get the well-managed about the water resources to meet the minimum demand at least. And in China, for water pollution control, we have a lot of rule, okay, policy and regulations. First is the EIA law and also economic promotion law, water law. It was proposed or established in 1988, okay, and later in 2012, also they revised for that. And also we consider about water and land conservation law, and also air pollution control law, and also water pollution control, and also prevention and control law. We have a lot of laws and regulations proposed, by the Chinese government to protect the water resources. And to achieve the integrated water management, we should have different measures. Normally we consider about measures, institutional measures, and also engineering measures. And for those measures, I think before we said integrated water management is to approach or tools or processes. First, we should consider not only for the management, it means at each stage we should consider about integrated, integral, the rules. First, we will focus for the measures for the strategic planning. It have long-term, mid-term, and also the short-term planning. Normally for the mid-term, in China, we have different phase, for the planning for the national level, for the economic development, and also for water. And also we should change, regulation and also policy adjusted to meet, to solve the problems. And next one is the integrated water management in China. In China, we have the rural business commissions. We have 7 big rural business commissions, belong to the Ministry of Water Resources. And for the institutional level, the national level is the Ministry of Water Resources, and also Ministry of Environment. And each province, each city, and each county, and each town, they also have the Department of Water Resources. All those for different levels to management, to manage the water problems. And also we should consider next one is strengthening the economic instrument. It means economic tools are also important. Not only consider about technology, but also economic tools, about money. And for the pollution control in China, we also have different ideas for that. One is the urban pollution control, and also industrial pollution control, and agricultural pollution control. All those to reduce the waste load into natural water bodies, and also improve the water quality monitoring. It means we should do the monitoring to get more data, to do analysis, to predict, to do simulations about water quality, or the pollutant transport in the water bodies. And also the planning work is very important, and also capacity building and environmental rights and the public participants, In China, we have the water actions. The first one is the most important for the management, the 3 red lines for water management. For the 3 red lines, one is the total water demand. It means until 2030, the total water demand for China, for all the China, is about 600 or 700 billion cubic meter for water. Okay, it's limited. Okay, it's a limitation. If above that, it will have the bigger problems. And the second one is the total waste. The red line is for total waste load discharge. Okay, the third red line means it's water user efficiency. Because now in China, the water user efficiency for agriculture, for industry, very low, is about 50%, 52%. And the government say we should improve the efficiency about maybe 60%, okay? And also the central government talk about the water management. The one is the water ecology civilization. And also we say that now it's very popular in China. This means green, the blue water and the green mountains are as good as the mountains, okay? As good as mountains of the golden and the silver mountains. It means very delicious, maybe, or very valuable, okay? For the green, we talk about economic development, we think that the green GDP is the most important. Okay, we need water, we need the clean water for our life, for our living environment. Okay, this is all for my presentation, and for the conclusions and recommendations, I will leave it here. Okay.
All right.
Okay, thank you for your attention. Okay, I'm very sorry, maybe too long.
Don't worry about it. Thank you very much for your excellent presentation. Now we will enter a discussion period where we will ask the speakers to clarify some doubts that we have received at the chat. To start off, I would like to ask Dr. Wan a question. It is the following. What plans have been, excuse me, that was not a question. What are the possible effects that the country is facing up trying to fulfill the SDG 6?
I'm sorry?
I'm going to repeat the question. What are the possible effects that the country, your country, is facing trying to fulfill the SDG 6?
I think, now in China, because China is really bigger first, right? Second one, I think, is about SDG 6. It's really good idea for the developing countries. I think at the beginning in China, normally before 1980s, we have, the economic conditions very bad, okay, during that time. And also for the industry, very not developed. So we have less, pollution, no pollution during that time. Okay, the water is clean, is good, can be used directly. Most people can take the water from a river directly to be used for the cooking. But after, 1980s, with the rapid development of the economics, we have lost wastewater, or waste load discharged into the water bodies, into rivers, no treated. We have the bigger problem for the water pollution, okay? And so now the government, to achieve SDG 6, we think the pollution control is the most important things. The first one, we talk about now the black water, dirty water for the urban rivers, for the restoration of the water body. It's for the pollution side. The second one, I think, for the water shortage, because in China we have a lot of problems. One, the most important one is water shortage. Before they think water shortage is the drought, is for agriculture, okay? It's nature. But now we also consider, in the North China and the Northwest China, we have less precipitation, rainfall. 1 year, the rainfall there may be about 10 millimeters, less than 50 millimeters, okay, 1 year. So they don't have enough water. So now the local people, they just collect the rainfall, use some instrument for the cooking. And the Chinese government now, each village now, they should have the drinking water supply. okay? And 30 years ago, maybe the most North China cities, the small city like the county or town, they don't have the water supply company. Now they have. Before they just take the water from wells, use the groundwater, okay? But now they have water supply company or water plant to treat the water to be used for the drinking water supply for the people, for the urban people, and therefore for the village. I think it is the most important thing in China for the SDG 6. And as some professors and some people say before, for infrastructure, and also in construct a lot of reservoirs before, but at the beginning, before 1960 or 1970s, in China, for the reservoir construction, the most important purpose or goals for the flood control, for the drought, okay? And also for the power generation. But now in North China, most reservoir, now they're changing the rules or purpose. Before the reservoir for the power generation and for the flood control, now we don't have enough big floods there, okay? And now they're changing the shift, the purpose from the power generation, from the flood control, now for the drinking water supply, okay? So I think the Chinese government, they also changing or adjust the policy and the regulations to meet the minimum, the demand for the water, not only for the domestic, okay, for the drinking water supply, and also for the agriculture and for the industry use. If you go to China, North China, we can see a lot of reservoirs there. Most important role is that, or only one role maybe, just for the drinking water supply or for the industry supply, water use. This is some answers. I'm not sure is meet your ideas or not. Thank you.
Thank you very much for your answer. Now we will move on to the question and answer session for the other roundtable, the one that was presented at the beginning. We will have a general question for all speakers, and it is the following. How is your country managing to establish this topic in order to fulfill SDGs 9 and 15? We can start off with Dr. Grajales, if you like.
Oh, great. Thank you. Well, here in Panama, we really have a challenge ahead of us. And first of all, the challenge is, I'd like to say it in a quote, if I may, from Dr. St. Georgi, who is a Nobel Prize. He says that research is four things, right? Brains to think, eyes to see, machines to measure, and fourth, money, right? So the main issue we have here in Panama is the budget. Right now, there's a very low percentage of the GDP that is being assigned for research and development. And from there, we have a whole range of limitations that stem from that issue. Now, getting into the topic of the SDGs 9 and 15, which is actually the topic of this table, I have to say SDG 15 is clearly included in all of the national policies that are out there for research and innovation. What we're missing is SDG number 9, right? And the issue here is that if they don't include SDG number 9 and force the research to find a way to innovate on infrastructure while respecting the environment, then it's going to be very difficult to move forward, right? Now, the other issue we have here is policy making, right? We can do the research, as it was mentioned earlier in the morning, we can do the research, and as a result of the research, we have some results and more questions to answer, right? And the issue is to how to involve the policymakers in the country. Now, said all of these, what Panama is doing truly, we have a very strong body of environmental engineers who are working endlessly to support research on terrestrial ecosystems, right? And so that part is moving in the right direction. And I would say what we need to do is to find a way to do both of them. And that's kind of the challenge for us. So I guess, I don't know who's next. Ana Isabel.
Thank you for your answer. Can Dr. Schwab answer the question next?
That is it's a very rich question. The answer is very similar to that Dr. Grajales just gave us, that we lack nothing in the way of expertise or the understanding that meeting these goals is necessary. What we really lack is the motivation to do so. There's this is a sort of a very poor political climate in the U.S. right now to take such steps. There may be some changes soon that could usher in a little bit more empathy about being more green in our approach to things, more environmentally aware, looking at things such as long-term longevity of what we're doing. But at the moment, everything is motivated by the fourth factor that Francisco gave, and that's money. You know, it's and if there's no monetary motivation to do this, then there's just very little movement that's seen. So, wish I could be more hopeful. I mean, we have, like I say, we have all the capacity to do what's necessary. It's just the underlying push.
Thank you very much, Dr. Schwab. May Dr. Chen proceed?
Okay, I'm pleasure to share my opinions. And actually in China, and after very fast developing for 2 or 3 decades, and it triggers a very serious pollution on the water. And so, and today, even in the recent 10 years, sustainability and the newly resources and the new materials is our government goal. And that say our government is starving for the technology developing and hunting for the sustainability in all domains. For myself, I'm the guy in the railway projects, and our government push each people to develop the sustainable materials. For example, if I do the research, if I apply some project with a sustainable idea of sustainable materials, I can get more funding. It will be easier. Because I'm only a teacher and only a professor in a university, I don't have too much. It's for a whole plan of a whole city. I just want to say, starving for the sustainable development and the sustainable materials is our goal. It's our government goal. And just Dr. Guan said, 10 years or maybe 15 years ago, there's too much river and lake pollution, but things could change very, very quickly. For example, he showed the Thai lakes algae green pollution. I think so nowadays it's getting disappear and disappear. I know that lake very much. I think that today it's quite different from the pictures showed in 2011 or 2007. It's quite a difference. So we are starving for the development with sustainability. That is my idea. Maybe Dr. Xiao can say something. She is young and active than me. Dr. Xiao, would you say something?
Your microphone is off.
Yes.
Don't you?
Oh, sorry, I forgot to turn on my mic. Yeah, my background is mainly on transportation geotechnics. So I'm not quite familiar with water or other things. But my presentation was addressing sustainability development goal of I forgot the exact number, but I think the theme for that goal is human is life on the land. So yeah, but regarding the water side, I'm sorry that I don't have much background. Yeah, thank you.
Thank you very much for answering the question. Due to time constraints, we will not be able to ask each question we have received. However, if you still want to have it answered, you can send them to each expert to the email addresses that will be shown in the following minutes. Dr. Fabrega had to leave, so I would like to extend his deepest apologies, and we hope you understand. To close off, on behalf of the Technological University of Panama, we would like to thank each expert for sharing their knowledge and experience with us today during the closing work tables. Thank you kindly to everyone who has interacted in the chat with us and for the time you have dedicated this afternoon to listen to these work tables that were presented and had interesting topics about current issues. On behalf of the International Affairs Office, please note that this session, as well as both work tables, have been recorded to be consulted and shared amongst researchers, students, and other scientific communities. Thank you as well to everyone else who made this first international virtual colloquium possible, and have an excellent evening.